We'll take just a moment.
Okay. Oh. Ted, could you turn that light on?
Okay, we are live now on YouTube, and so we're going to begin our meeting. And so just want to welcome everyone to the April meeting of the North Jersey Astronomical Group. My name is Kevin Kanad. I'm the president of the club, and we're going to be having a presentation, or start our meeting today with a presentation all about Mars. And our guest speaker is Michael Dean Lewis, and he's a solar system ambassador from JPL NASA, and he can tell us a little bit more about that. And feel free to introduce yourself, Michael, and we'll get started here. Please keep your microphones muted during the program. If you have any questions during the program, you can use the chat, and we can try to handle those questions during the program, but some of them also at the end as well. So let's get started. Michael, if you'd like to introduce yourself, feel free.
Sure. I'm Michael Dean Lewis. Thank you for inviting me, Kevin, and the rest of you, Mary Lou West, for this special opportunity to present to you the Mars rover, latest edition, named Perseverance. We had called it earlier Mars 2020. A little bit about myself. Mary Lou West had asked me earlier, how did I get into the NASA Solar System Ambassador Program? Well, I was teaching physics in 95, 96. And I was just starting to use the internet in the high school, in our school. And I saw on NASA website, I was very interested in the Galileo space program. I had applied to be an astronaut for 4 or 5 years because I had learned to fly, I'd done PhD, I knew my stuff about space, and I knew how to fly. So I wanted to go into the outer space, but it wasn't for me, though I spoke to a few people in the program. I wasn't selected, though one of my best friends from high school got picked. That didn't bother me much. I enjoyed what I did in graduate school and what I'd learned, and I enjoyed teaching the high school. But I was on the NASA website looking at Galileo, and the probe, this is in December of 95, the probe had been released from Galileo and was going to enter the atmosphere of Jupiter. And so all the problems that had occurred during the mission of Galileo to Jupiter I had followed. But this was particularly interesting. And I saw what the NASA presentation had given on the internet. And so I saw the fellow who had done it, Ron Balke, and I sent him an email and I said, look, Ron, the way that you've presented Jupiter isn't the way it should be. And from that, we communicated. I began communicating. He showed me, well, I meant to show this, and it wasn't really wrong. It was just that I wanted people to see it from this perspective. And I understood, and he contacted me. We kept in contact, and then he asked me if I wanted to be an ambassador from Jupiter and present about the Galileo space program to the public, because they were looking for people who would do that. And I said, sure, I'd be glad to. So they sent me slides and packets and things to give out to audiences, and I began presenting to the public. I presented to the schools, and that began and then they discontinued that. They discontinued the program around 98, 3 years later. And so then they asked me if I wanted to be a solar system ambassador. Wow, no more making fun of me. Hey, there's the guy from Jupiter. Now I was a solar system ambassador from Jet Propulsion, a little more authenticity to it. And that was back in 99. And they almost canceled that program because there were two failures with the space program at that time. One was the Mars Polar Lander, and the other one was called the Mars Climate Orbiter. And those were two significant problems. Though the little Sojourner had made the successful trip to Mars, those two other programs that came after it really put a scare into jet propulsion, and that those failures really impacted because of the internet. The internet was getting hundreds and thousands of hits on the websites. They had these mirror websites at the time. They didn't have enough broadband to handle all the people that were going to the sites. And I got this letter and I said, no, you can't cancel this thing. We're presenting, we like doing this. And at the time I was going to New Jersey State Museum. I was going to different astronomy clubs, one in Ocean County and at the Princeton. And it just wasn't right to do that. And they didn't cancel it. So I'm one of the original. I know if I'm not I might be the latest, the one that's been there the longest, but I tell you what, it's been a great ride, and I hope that you like the presentation. Let's get on with it. All right, so today we're going to talk about the Mars Perseverance rover and how it was developed. So let's start. It was begun way back around 2016. They began planning this 4 or 5 years ago, 4 years before things began. And the launch was a big thing, the 2020 launch. There was a lot of things involved before that. And there were these launch windows that occur. Now, the launch window for the Mars, this Mars rover 2020, now we call Perseverance, was pretty good. I mean, it was a robust one. It lasted from July 30th till 8/15. The worst one that we ever had was when we launched to Pluto with the New Horizons spacecraft. That had a very small window, and if we lapsed at all within a few days, it would put another year or two on the mission's time to get to Pluto. So this one was a very accurate and very precise. The weather turned out great, and the Perseverance, the flight, it took off on February 18th. It took off in July 30th, exactly on time. It was supposed to launch at 7:30, and it did. It was at that time. And then when it was supposed to land, it was supposed to land on February 18th at 3:55. And sure enough, this mission has so far been flawless. And I must say that since those two failed flights in 1999, going to Mars, we haven't had one failure. The United States has surpassed and achieved one of the most remarkable records ever of sending spacecraft to Mars. And if you think that that is an easy thing to do, wait till I show you a few slides and show what it's like for planets that are orbiting at thousands of miles an hour going through the solar system. And then, of course, we're traveling in the Milky Way. Okay, so here's some downloads that you can find on the website. And here is a link for that. And you can print yourself some stickers, or you got a lithograph, and we've got fact sheets. We have rover model. We have the Ingenuity helicopter 3D model. So you can look at these things and you can download them. You can print them out. So also the Perseverance project is on Twitter and on Facebook. All you have to do is put in there NASA's time. I was allowed to walk around, no problem. Unfortunately, now you can only access it through bus or with special permission invitation. Okay, so The launch time was at 7:30 on July 30th. That was last summer. And the flight, I said, was spectacular. I do want to show you a nice little website that is given to us that we can look at the solar system. So I need for you to tell me if you can see this. So if one of you will unmute, can any of you see this page that I've just put on with the solar system?
No, I don't see it.
Okay, so what I need to do is a new.
Probably have to stop sharing and share again.
Yeah, I've got to go to this share
Yeah.
here. So let me go there. All right, now you should be able to see it.
Yes, that's good.
Got it.
Okay. All right, good. So you can see here, this is a current picture of the solar system, and it's called Eyes on the Solar System. And we can scroll in and you can see the planets, and you can see some of the NASA missions that are within our solar system. Okay, and one is the Parker Solar Probe, which is going to do this flyby of Mercury, and it's one of the most exciting missions. It has been on Amazon Prime. I think they've got something on Netflix on it, and you can read about how that mission. The Parker Solar Probe is right into the sun's corona. It's the closest we've ever sent a spacecraft to it. When the mission was on, I was showing this, and now you can see what it's kind of empty because you don't see anything other than the Parker Solar Probe and the Osiris. But there is another mission going on called the Psyche Mission. You can see it here out beyond Mars's orbit. And then you could see Halley's Comet's way out there in the distance. Of course, that's not going to be seen for a long time. But anyway, so those are other missions that are there. Okay, so let's get on to the next one. So let's go back to the program. All right, so let's get to the slideshow. We can see more of it. And so, all right, this is an animation of it, and the slideshow with the just an animation of what the spacecraft looked like leaving Earth. Everything went flawless on the 30th. You can look on YouTube and see and ask to see it so that the total picture of how the spacecraft went to Mars is shown. And so that's just one little picture, but you can see in how it's held in a little cocoon there, where you've got this shield in the front. That's a shield that's showing it's being protected in flight, and you could see the equipment behind it. All of that packaged nice and neat from Jet Propulsion. I'm not going to talk about all the things that were done, the testing with the helicopter and the clean room before launch. Let's just look at the mission itself, okay? And a lot of things that aren't known by the public, and this is one of them. And so those of you who are astronomers, this picture should be pretty good for you to see. So let me just do this so you can see that, right? So you can see it a little bigger here. All right, so what you're looking at is in the inner ring that's blue, that's Earth's orbit, and on the outer, that's a black line, is the Mars orbit. And in the orbit in relation to the months, considering seasons, because both Earth and Mars have seasons. And you can see here that when the spacecraft was launched in July, it was autumn on Mars, meaning the temperatures are similar in degree. It's much colder on Mars, but the idea that it does have an autumn and a winter. And so in flight, while Perseverance was traveling to Mars, the seasons change from autumn to winter. And then by May on Mars, it was our February. And on February 18th, it was a nice spring day on Mars. This is all planned ahead. Most people don't realize how that is done because, of course, the weather on Mars is stormy. They do have dust storms, dust devils, and things like that. And they cover the whole planet, very, very traumatic. And you can see that from telescopes on Earth. But anyway, the spacecraft, it landed on a nice, like I say, spring day, and very successfully did so. And it was May. It was May on Mars, while it was February for us. And currently, we're now in April, so you can see the line here. If you could see my cursor, we're in the middle of April, and it's now July. It's turned into summer in the northern hemisphere of Mars, right? Because it does have a little tilt. And so let's take a look at where the landing site is occurring, or did occur. So here we have some places on Mars that you can see with a regular telescope. If you've ever been up to Jenny Jump Park, I recommend that you go there. There's the United Astronomy Clubs of New Jersey are there, and they have several telescopes, reflectors and refractors. You can look at, on clear nights, you could see very clearly Mars and the rest, like tonight, right? Tonight is, Mars is in the sky, and it's been in our sky for a while. So you could see the North Polar region. You could see Syrtis Major and Huygens Crater, Hellas Basin. So where did Perseverance land, and why was this site picked? So it was Syrtis Major, and you can see here it's up in the right-hand corner. And let's take another look at it. Okay, so this is much more delineated. And Syrtis Major is in the middle. I picked this slide for that reason. And you can see here this Nili Fossae region of Mars. And Mars has been pretty well named for different features over the years. So the place that was picked is called Jezreel Crater, which is on the north part of Syrtis Major, just to the west of Syrtis Basin. And that place that I showed you, Nili Fossae, it's just south of it. So Jezreel Crater is picked, it's not Jezero, it's Jezreel, for several reasons. And one of them is that we could tell from other Mars missions. Now, like I say, I've been doing this for many years, since the 90s. And the first orbiter that got there back in 2002, 2001 actually, it just celebrated its 20 years being around there, the Mars orbiter. It was able to give us a good gravitational field and a good, it has a laser altimeter reader on it, and the different heights of these places. So from that, its major mission was to map out where there could be possible water, which it did. And so that mission is still continuing, Mars Odyssey. My kids, that when they were in high school, I told them about it before they launched, and we went through the whole thing. And when it got there, of course, they still keep in touch with me, 20 years later, and tell me about that. They thought that was one of the most major things in their lives, remembering that. Anyway, here we are on Mars, Jezreel Crater. Now, there's challenges to land on Jezreel Crater because of the technology improvements. This is the good thing about unmanned spacecraft, unlike manned spacecraft. We can take hardware, and this is happening ever since the 90s, where, back in the day, we had one of those 20 megabyte computers. Wow, that was like most amazing thing. megabytes. Those of us who went through the computer revolution and its development, now we can put on terabytes in half the space. But anyway, you can see here on this picture, because of that unmanned, and we can pull stuff right off the shelf, brand new, we can harden it. We have new materials, alloy metals that protect our spacecraft. The distances involved in landing can be now very much targeted within a kilometer or so. And that's what you see here in this picture. In the top right, you can see Mars 2020. It has an ellipse of 7.7 kilometers by 6.6 kilometers. All right. And the one that the Curiosity MSL, it had, this is back in 2012. This is 8 years before the launch. So it's still 8 years in the differential between the two spacecraft. It had an ellipse of 25 kilometers by 20, and we were able to land that. And after what we've learned from this mission and its success of landing the Perseverance, we're going to be able to land within a kilometer of where we want to, which is amazing. You know, when we want to find that place, Mars Polar Lander, the one that fell down, we still don't know where it fell, but it landed and it went down some crevice, never to be heard from again. So anyway, you could see here that the 2020's ellipse is 10 times smaller by error than MSL's and 300 times smaller than the area of the Pathfinders. Pathfinder's landing right in 2002. All right. So we've really come a long way. The Phoenix Insight, who's been doing the measurements on the earthquakes and the sensitivity of that with the interior core, trying to figure out what's on the inside of Mars. That had one of 130. Now, the reason is, and this is the thing that I like to talk about, I hope that you find it interesting, because here we are on Earth, right, far away, and we're looking through our telescopes. What's going on? You know, how can we land? This thing is able to land because it has a new projection system. And the new landing technique, it looks like this, right? It takes the pictures before, it takes the pictures as it descends, and it takes pictures as the orbital map. It's all done autonomously. It's all done pre-programmed. Everything is set to go, and it's compared to the orbital map. It has enough hydrazine propulsion in there to move it to the side, to get it out of any problems if they're encountered on the way. So this is terrestrial mapping at its best. Okay, so the same systems that were used for MSL, the Curiosity rover, were added. So there was cost savings involved. Everything wasn't just new. It was very much like car development, where you can take things that are on the shelf from a previous model, rearrange them, and make it into a new model with improvements, right? Well, there was new hardware, but there were a lot of other hardware brought in from the Curiosity rover. And so we have this EDL, this is the entry, descent, landing technique, where these new capabilities were brought. Now, this is called the Sky Crane. This is the Sky Crane technology that was brought in. And this is one that was used also with the Curiosity, but this one involved a much bigger, the Perseverance is as large as a car, bigger than a car, actually. It's like an SUV, while the Curiosity rover is like a go-kart size. All right. So just to give you a comparison between the two. All right. So how do they test? They test it on Earth. All right. We use these helicopters, quick flight. They fly them out. I know, can you see this? Can you see the motion? All right. So the helicopters are tested. As you can see here, we have a facility out in California, Cold Stone. It's near Death Valley. again, just from a different angle. Okay, so that's that. Now we'll go to the next one. Now, here is the camera in operation above the same range that you saw above the mountains. It's a great way to test what's going on a California summer morning. You can see the clouds in the distance over the Pacific Ocean, and they're up at about 10,000 feet. And the camera is looking, you can see Elvis singing away down there, looking at the scenery. So what's the camera doing? Well, here, it's doing this. You can see here 3 different images on one photo. And on the left is the big photo, right? So you can see there that on the left, it's getting an idea of where are there possible. It looks green. That looks good. Then on the top right, we go to top right. All right, so we're coming in a little bit better, getting a better view. We got the green, we got a yellow, and then the one on the far right, we have the green in picture. So let's run this just to give you an idea how it changes as the spacecraft's coming down. There's multiple sites that are picked. The computer can do this now. We can generate. Of course, computers run very much quicker than we imagine. It's difficult to believe how quickly they do until you see all of those operations. You work on a supercomputer as Los Alamos, you do the supercomputer, it can work and work and work and get these calculations done very quickly. And this is what's happening here. So it targets the site and finds the best place to land, and that's where it's going to go. All right. And so it continues to do that, the generation of the sites until the best sites are picked. All right. So, and it worked. The thing is that all of these things worked well. They worked so well that we've learned so much from it, from this terrestrial ranging navigation, that, like I say, it's going to be within a kilometer or maybe even less than that. Now, we are looking to go to Europa, right? And we're going to do a mission to explore Europa to find out. Now, Europa, for those of you who don't know, is the second moon, Galileo moon. We call them Galileo moons because Galileo, he's the one that discovered them when he looked through the telescope. But we found that there was an ice region on Europa back when the Galileo space program was in full play. And when Galileo became one with Jupiter, we were very sad about that. But we learned quite a lot about Europa, Io, Ganymede, and Callisto. All right, so here's our TRM. Let's not gone on that too long. So here are some other improvements that were made in gathering data to find out if they'd work for future missions. Again, these things are microelectronics, and they had a suite that is a variety of these pressure and heating sensors that allowed the Perseverance to land successfully. All right, so the cameras. There are several cameras involved, and you can see them here. There's 6 of them that were used for the descent, for the entry, descent, and landing, the EDL. And you can see what each one of them did. They got one that looked up at the parachute as it deployed, one that looked at the sky, looked down. Now you'd think that all these things would cost a lot, but actually this mission is very economical because, again, it's very similar to buying computers as it was back in the day. You can get a computer now, a very robust computer, for a couple $100 that can blow away any computer that was made in 2008. All right, just that's the nature of what's happened with the electronics and the engineering. Okay, so those are the things that were there, and there were lots of tests that were made. And from Odyssey, right, we got the surface gravity. We knew where there would be more acceleration or less acceleration. And all these things were done to reduce the risk of any problems. They worked on the parachute, all these things done. They worked on testing. This is looking at the entry level, right, to make sure that the heat shield would work. That was done in this rocket was deployed. They brought it into Earth, and they simulated the Mars entry with Earth. So if the spacecraft could handle the entry from outer space on Earth's atmosphere, with the density of the Martian atmosphere being about 1/50th of the Earth's atmosphere density, they knew that they could withstand the heat from that. All right, so that was tested. And then here I have an interesting one. This is all planned out, all pre-programmed. So let's watch this video real quick. And it just shows the decisions that are made autonomously as the spacecraft entered the Martian atmosphere. That was on February 18th, almost 2 months ago. So you can see here on the upper left, that's the spacecraft, that grayish thing, and it's coming in, and you can see here how high it is. All right, so that's actually in meters. So it's not in kilometers. The clock was a little bit out on that one. So at this time, it's like 3,000 kilometers up, and it's going to come down, which it's all right. So it's entering. You can see it on the left. Its speed is pretty fast. If you multiply the meters per second by about 2.2, you'll see that it's traveling over 10,000 miles per hour at this point. All right. So as it's coming in, it's descending quickly. And of course, it's already got its sights on. The entry was pre-programmed that it would enter at that angle. All right. So there's a lot of math involved. Those of you who are aspiring to be astronauts, or if you'd like to work for NASA, do well in math and enjoy being part of that. You can build it. So you can see here it's coming in. It's now at about 1,400 kilometers up above. Let's say in terms of miles, that's around 200 miles up. Here it's coming in, and it's going to show you how the sites are picked. All right, so the parachute deployed. It's now at, let's say 10 miles up, and now it's coming down, right? Its speed has slowed significantly to only going about 400 miles an hour. So that's how quickly the spacecraft was able to decelerate. And now it starts to probe, since it's in the region of where it's going to go. Now, remember, it does have these rockets on the side that can push it laterally to get it into the position where it should be. So as it's coming down, you can see here, it's now at Mach 0.427. And this is to the speed of sound at the Martian's atmosphere. All right, so you can see there's lots of fuel left. It's got 382 kilograms left, and there's like 96 fuel remaining. This is for any contingency, right, where it'd have to burn it. Now, we are looking to send a mission to Mars where it will pick up. It will actually use the sample that'll be taken by Perseverance and return that sample to Earth. All right, so you can see here how the detection is done using infrared and ultraviolet to find out where the best landing site is. It's got they call it a MOLA, where the laser altimeter is figuring out how high each of those surface areas are in terms of their flatness. Okay, so as the spacecraft gets closer and closer to the surface, right, there's a sensor that tells where it is. That's what the pressure and the temperature sensors are. It's warmer at the surface of Mars, just like it is on Earth, right? And then you could see here that the parachute is still there, and now we've got the spacecraft. It's figured out where to go. It's coming in, And there we have the rockets. The sky crane has been slowing it. It's slowing. And there the sky crane deploys and the Perseverance drops. And now you have the landing. And then once the landing occurs, the crane itself is blown off. It's got rocket motors on it and it flies away. So it doesn't interfere with the robot as it's landed. And there it is. So that's what happened on February 18th. Yeah, 3:30 in the afternoon. Okay, so let's go on. Hope you like that one. All right. So here's another picture of it, the trailer. Here's a little video of it. It didn't play. Oh, what happened? Here we go. Had to load. Okay, so that's the countdown to Mars that occurred. Did you see that video? Did everyone see that or no? You did see that. Okay, good. All right, you can't tell what's going on. All right, so anyway, there we are. And so we made it to Mars successfully, right? Okay, so let's go to the next slide. And I don't want to see it again. Sorry. All right, so there's the high rise, and this was taken at the beginning. Now, unfortunately, it's too bad I can't show you too many pictures of Perseverance and what it's done since it's landed, because that's the spacecraft is still being, the rover, tested, and the different machinery that's on it is being used. I'll show you a couple of photos, but nothing like we're going to see in the next few months. The helicopter, I want to show that in a little bit, that was designed, has not yet been deployed to fly. It has been deployed to the surface, and the Perseverance has left it on its own, and it has survived being by itself. However, it hasn't flown yet, and we're waiting to hear about that. Okay, so here is a picture of the Mars Reconnaissance Orbiter, which has the largest cameras, had the largest cameras to date, orbiting Mars, and it was able to capture actually the descent of Perseverance, which, it's pretty cool how we're able to coordinate these different spacecraft to watch it as it worked, as it descended. Okay, so here is a picture. This was one of the pictures first published by Perseverance from the sky crane looking down at the rover. And then here's one of the first pictures that was published, and there haven't been too many since then. So very clear picture. This is true color, and you can see the horizon of Mars. It's kind of got that pinkish orange color, and you can see the rock formations. This is in Jezreel Crater, where the rocks in the formation there, we're going to be looking. Then there's one rock there in the forefront, very interesting, one of the green rocks that it's now being looked at. Okay, so that's that one. And here's one of the wheel from the bottom camera. And I can show you that. So there we are. We are on the Mars surface. Very sandy looking. Okay, so there are some interesting web pages where you can look behind the spacecraft. You can look at how it was built and how it's tested, and the Jezreel Crater flyover. I really like that one, so I'm gonna show you that one, and also the sample collection animation where they have the robotic arm going out and grabbing some of the soil. So let me show you the crater flyover, and I think I have to go to a new share on that. So let me see if that is true. Yeah.
Dean, we have a question.
Oh,
Of
go right ahead.
Jeff Carlisle asked, are there any system failures detected yet?
No, not yet. Not a system failure. There was a communication problem with the helicopter to the rover itself, but I haven't heard anything new about that. That's why there was a delay in the. That's why Ingenuity, that's the name for the helicopter, hadn't yet been flown. So there was some kind of glitch with that. But other than that, nothing. I'm sure they'll figure out what to do with that as well. Don't worry. We're gonna see that helicopter fly real soon. Good question. All right, so here's what it looked like with the flyover. Just like to show you that. This is I hope you can see this.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet.
Michael, leave your microphone on. It's cutting off the sound.
For life to exist on the Martian surface today. But after Jezreel Crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars climate changed, Lake Jezreel dried up and surface water disappeared from the planet.
Okay, so I'd like to stop it right here just to show you the difficult navigation of landing. You can see that those are cliffs that at the bottom, you can see the crater, the middle crater. Jezreel Crater is much bigger than that, but you can see the little innie there at the top, and then as you travel south downward on the picture, you could see the cliffs. And of course, this is above the surface, looking down. This is the Mars Reconnaissance Orbiter that's been looking at the site. Yep, that's how clear we can see things with it. And that's the part of the ellipse where we want it to land. All right, so let's continue.
An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. A canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan shape.
Okay, so just to show you where the rim is out here where the hand is. All right, that's where the rim of the crater is. Okay, that's the rim of the crater there. All right, out there. And here's where the water flowed in. The water flowed in from here. You can see there's definitely a passageway. It looks almost like a road that was cut, a dirt road on the surface of Mars, right? Into where this water, the delta, right? We know delta is accumulation of rich nutrients from the river, and they accumulate and they then deposit it. Of course, we use that for enriching the soil. That used to be done. The Nile River, of course, you know, the famous Alexandria Delta and all that. But anyway, the land is here, and this is where we're exploring. So we're definitely looking for microbial
Delta.
life.
The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. You can picture waves in Lake Jezreel beating on a sandy beach. And finally, we will press on to the crater rim. Jezreel Crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
Okay, so that's that one. And now let's return. Okay, so that was the Jezreel Flyover. And you can see the pictures that are made by that reconnaissance orbiter in the 3D are quite amazing when we look back and analyze when we were first beginning to explore Mars. Is it a place where humans could move? That's one of the questions, right? Where we want to know if that's in our future to leave the Earth and to live on Mars. Of course, we haven't had any these museum. When we do return and this COVID thing is behind us, we hopefully, when there are presentations given, for instance, at the Philadelphia Museum, the Franklin Museum, the New Jersey State Museum, we get people together. We do this at American Museum of Natural History, and you will see that there have been many engineers who have looked at if we can inhabit Mars and how that is if it's a possibility. All right, well, getting back to the rover, there are places on the rover you can on the website for Perseverance where you can actually interact and you can play with the rover and look at different parts of it. Without spending too much time, I know it's getting a little late in the presentation, but just to show you real quick, this one here where you can meet the rover and interact with it. And if you can't find any of this, you can always send me an email through NASA. I don't know if you can see this here, but this website is actually allow you to explore in a 3D visualization the Mars rover, and you're able to manipulate the different parts of it to show what each of them does, and you can learn about their components. All right, so it doesn't take too long. If you do see what I'm seeing, you can see here is the rover, and as you scroll over the different parts, the wheels, for instance, you can click on them and you'll get more information, right? They're made of aluminum. They've got cleats for traction and curved titanium spokes for springy support. Now there's an exact replica of Perseverance at Jet Propulsion in Pasadena. And this has always been the modus operandi with our spacecraft that landed on Mars, beginning with the little Sojourner back in '97. That this exact replica is used in case of problems that occur on Mars and that can be solved on Earth by simulating what's going on Mars on Earth. And it has worked tremendously, right? The Spirit and Opportunity were in operation until just recently. The one Opportunity lasted for almost 19 years in the Martian atmosphere. It hasn't been able to return to service since last year. But the idea of having another exact replica is really one of those things that allows us to design a better way of getting through those sand dunes, because both Spirit and Opportunity had problems getting stuck in the dunes, and they had to do all sorts of tricks to get them out of the being stuck. All right, so you can learn about with showing parts of the rover. Okay, so let's go back. Yeah, let's go back to where it was and continue with that. All right. So just I'm going to get out of this. Let's go back to the slide presentation. All right. I don't know why it's not going there. Okay, there we go. So these are where you can look at the 3D model, no labels if you want to test yourself what you know of it. All right, so here's the helicopter trailer that we were given. And I like the one with the rover and the helicopter just to show you what's going on with both of them. All right, so let's take a look at that. Okay, so there you have the animation of what it will be like when this little Ingenuity helicopter is brought into operation. All right, so let's go on to the next part. If you'd like to see more, just visit the website, right? This is the website about the technology if you want to learn more about the specifics. It's a very light helicopter. It only weighs about 4 kilograms. And everything is packaged in that little box there that's suspended from underneath by the legs and underneath the propellers. It has a 2 propeller system. They rotate 2,000 or so RPM, 2 to 3,000 RPM. All right, so it is the first test powered device that we've used that can actually fly in the atmosphere on its own ever, besides on Earth, right? So some call it a drone, and in a way it is. It is a drone on Mars. All right, so, and there's lots of interactions. If you have youngsters or others who are interested in learning about science, technology, engineering, and mathematics, we have a STEM toolkit that is available and will help you in understanding more about the spacecraft, the rover, and everything in between. Okay, so the main objective here of the spacecraft, of course, of Perseverance, like I said earlier, is actually to determine if life has existed on Mars or if it currently does. We haven't found anything yet, though there was with the, if you remember the Viking 1 and 2 back in the 70s, there was an in-depth analysis made, and it was inconclusive that actual that the organism was discovered there. So it was decided that no, there has been no evidence as to date of having any life on another planet. Now we're looking at Venus again, but so far Mars definitely is noted for having previous water. And so again, we're characterizing the planet's geology, and we're looking forward to future missions where we will be returning these Martian samples back to Earth so we can look at them better with more equipment here on Earth. Okay, so that ends the presentation for tonight, and I hope that you enjoyed it.
Great. Thanks, Michael. We did have a question in the chat, and Chris is wondering, what is the relationship between NASA and JPL, and could you describe how missions are planned at JPL?
Oh, sure. Well, NASA, the headquarters, NASA is the place where all the major decisions are made. And there's coordination between the director of jet propulsion and some of the associate directors with the main administrative building. So when missions are are decided upon, anyone can actually participate in proposing missions. As a matter of fact, we just got news of about 5 missions that were given, I don't know, somewhere around $500,000 to look at different aspects of space exploration. And anyone can actually, you can apply. And this is what they do at Jet Propulsion. Jet Propulsion is just got people who are actively engaged in space exploration, so much so that they really, they plan. It's one of those places where it's a think tank of what we'll do in the future. And I remember when the first idea was floated about a glider being put on Mars. And I think that mission still may be in effect. And it was like, I don't know, 10, 11 years ago where that was proposed. The helicopter, the same thing. Helicopter, though, came sort of out of the blue, if you find out about the history of that, because someone had proposed it many, many years ago, and it was shelved because there was no way at that time the technology just couldn't handle all the computer wear. But like I say, the interaction between NASA and Jet Propulsion, well, JPL is NASA, part of NASA. And JPL gets a higher ranking, if you want to say, in terms of allowing access to other facilities like at Langley or at Moffett or at in the Glenn Research Center, Lewis Research Center, and or in the Ames Research Center, where things are tested, but then they're brought together. JPL is where actual building is done, where they have the hangars and these very very secure structures that can simulate extra Earth environments, and that's where the completion of the project is done for the spacecraft. Now, the rockets, those things are done like at Redstone Arsenal, or that's in Huntsville, Alabama, that facility, or in Utah, there's another facility done for testing rockets. So Jet Propulsion is the one that can pull it all together. I hope that answered your question.
Yes.
Yeah, and there was also another part to Chris's question about does JPL work with other organizations like SpaceX?
Now that I'm not so sure of. Okay, I really can't tell you that. I haven't had any meetings or conferences concerning SpaceX at this
Yeah,
time.
because JPL is really focused on planetary stuff, not the manned space program.
Correct. Yeah.
That's more Houston, you know.
Yeah, exactly. And one of the things, we look at the star systems, and I've been saying this for a long time about we do have the technology, and we've had the technology for many years now. I'd say for about 15 years, to send a spacecraft to the nearest star system and get data from them in our lifetime. Of course, that as I get older, we all get older. That is going by, but that capability is there, and it's one of those things where we need to get into figuring out why we haven't done that yet, why unmanned spacecraft haven't yet gone to like Alpha Centauri and visited. So yeah, and if you want to know more about that, it's another talk. So
yeah. Edward asks, or is thanking you for a great presentation. He's also wondering about China's Taiwan spacecraft, wondering how that will perform. That's coming up soon, I think.
well, I wish them the best. We don't have, as far as I know, any collaboration between the Chinese. We do work with the Japanese, but they're mostly on their own. However, the United States program is by far, if you look at our successes at this time, beyond anything that any part of the world has been able to achieve. Now, Europe has contributed. I mean, we had the Cassini spacecraft with the Huygens probe that went into Titan. That was built by the Europeans, and those things have worked really well. So I don't know how things are going to. I would like to have cooperation with China, but we haven't heard anything about that.
Yeah. Well, certainly the Europeans will be involved in the future of Perseverance, because the samples that you mentioned, they're leaving behind these sort of breadcrumbs on the surface of Mars. And of course, Europeans will hopefully build the spacecraft and the rover that will retrieve those samples and bring them back to Earth. So that's going to be exciting to see.
Yeah, that's another one. Exactly. And we'll be working with them for sure. JPL will definitely be involved in making that project work as well. For sure.
Yeah.
That's just the community. Europeans make really good product. If you've ever flown on an Airbus, they have a good consortium where they are cooperative big time. And it's not just in jet propulsion or in aerospace, but also in physics, particle physics, other parts of science as well. Chemistry, vaccines.
Yeah. I think that aspect of the Perseverance mission is pretty unusual for NASA. It's kind of, in a way, kind of speculative, because they're putting down these samples, but the spacecraft that's supposed to retrieve them is kind of not even a drawing board yet in a way. And so it's kind of unusual, but it's kind of nice to see that they're taking risks,
Right. Well,
kind of push the envelope, so to speak.
we look at we're looking at the Mars mission, but remember, we are going to be going to Europa soon. And we also have another spacecraft that's going around Jupiter called the Juno mission.
Right.
Has been mapping the northern, the poles big time. Right. So there's a lot of things that are happening. And of course, the budget of NASA hasn't grown that much. But the cost of unmanned spacecraft compared to manned spacecraft is so much less, so that we can do a lot of these missions and it's not really costing that much. That's why I still push for that. There was a guy named Freeman Dyson. I don't know if you ever heard of him.
Oh, yeah. Oh, yeah.
And I got to know him personally and through the Princeton astronomy group. He was very active about this astrobiology part, which is the part that we're looking at now with Perseverance. So I'm hoping that we'll find something there with this, and with the equipment that we already have on Perseverance, the soil analysis, the measurements, the spectrophotometry that can be done to determine if organisms did exist. You see some of those rocks that have those holes in them. I mean, come on, that looks just like something that organisms make on Earth in the rocks, right? These worms that eat through and enjoy the carbonates.
Yeah. Okay. Okay. Are there any other questions for Michael?
Yeah, Kevin.
Yeah. Go ahead.
Michael, can you talk a little bit more about this proposed or possible mission to Alpha Centauri, and how long would it take to get there? What kind of probe? And is that something that's realistic?
Sure. I love talking about that one because you hear like Neil Tyson, who I know Neil.
Mm-hmm.
I've known him since before he was anything. He was at Princeton. He was assistant prof. These guys talk about solar sails, Bill Nye and them. And unfortunately, that's not really realistic. There was a guy back in the 60s who came up with the idea of using lasers. And that's the idea that I know will succeed. So if we want to send a spacecraft to Alpha Centauri, remember that there's little attenuation of electromagnetic radiation in outer space, right? The only reason that we know that we don't really feel that is because we have such an atmosphere that protects us, the magnetosphere, and also the chemical atmosphere that we have, right? Mm-hmm. So in outer space, the density of particles is so small. So if we built a solar station out there with solar panels that could power a laser, we could put a small spacecraft similar to the Ingenuity, a small one like a CubeSat, and it could have these panels on it that would absorb that laser radiation. And over time, that thing could accelerate very, very quickly to near speed of light velocities, right? There's no doubt that I've seen already lab experiments where that's been done. I've been privy to seeing that. Why it hasn't been? Because I don't know. But that mission, you don't want to be going much more than like 0.4 or so C. But just think, this nearest star system was about 3, it's a parsec away, right? So like 3 light years away, if it's going at 0.4 C, well, what's that going to take? Around 7 years? 7 years to get there. Well, that's not, it took New Horizons to go from 2006. It took almost 12 years. It was an 11-year mission to get to Pluto, right? Mm-hmm. So here we have a mission for sending this spacecraft out with this laser beam attenuated. It's shooting right at that spacecraft, and just keep it going until it gets that 0.4 C. And then off it goes, right? And of course, it's got to be able to, it's got to have a little bit of rocket on it so it can anticipate if something's ahead. Because, you know, anything traveling at that speed encounters even a dust particle, it's all over. But the density of space is so light, I don't see why it can't be done. And I'm just going to keep talking about that. Thank you for asking.
Thank you.
Great.
Where would the laser be situated? In orbit?
Yeah, we could put it in. We could put it in one of those points, you know, that are stable on the
Yeah.
right. Yeah, just put it there, keep it there, and it's not going to move. You know, easily. It's in one of those points where the gravity is, and then just keep it right centered on the spacecraft. And it wouldn't be that much money either. It wouldn't cost that much. It will be done. No, the solar sails, forget all that stuff. That ain't gonna do it. You need power, you need that energy located, targeted specifically on the system, and let it fly, and it will work. And that's the way we could also travel between the planets quickly. I mean, it's still gonna take days or so, but once we get something like that going and built, and it's out there, why not? You know, we've got to have something to slow us down when we get there, right? Because you can't just get going slow. You know, it can't go flying by. That's the dangerous part.
Yeah.
But sending it out to the star system, that would be easy. And I don't know why we haven't done it. But there's technology is there.
Yep.
It's been there.
Very good.
Okay. Any other questions for Michael? Okay, I think we can wrap it up there. So thank you for your presentation, a really fascinating topic. And so hopefully we'll see some amazing stuff from Perseverance over the next couple of months and years. And hopefully we'll be able to see that flight taken off soon. So thanks. For the members of the North Jersey Astronomical Group, if you could hang